Welcome back to my channel. So regarding SSC public examinations 2022 last minute preparation series, in this I am going to explain as well as I am going to share few important concepts for the public examinations. So you may expect these for the exam, and don't miss these concepts while you are preparing for the SSC exams, right? So here the concept is about proving irrationals. Proving irrational. You can expect this concept for 8 marks in group A. So as per the new pattern, long answers for 8 marks consists of 2 groups, group A from paper 1 and group B from paper 2. Okay, so here this proving irrational comes under a reasoning and proof academic standard, right? You can expect a question definitely from this concept. So here it consists of 3 types. Type 1 is proving root A is an irrational, like root 2 is an irrational, root 3 is an irrational, root 5 is an irrational. The second type is root A plus or minus root B form. Type 2 is A plus or minus root B form. For example, 2 plus root 3 is an irrational, or 7 minus root 5 is an irrational, or 3 plus root 5 is an irrational. So it consists of one rational and one irrational. And type 3 is root A plus or minus root B form. Root A plus or minus root B form, consists of 2 irrationals here. So examples we can take: prove that root 2 plus root 3 is an irrational, root 3 plus root 5 is an irrational, or root 2 plus root 5 is an irrational, or root 2 minus root 5 is an irrational. So here you can concentrate more on this concept. Definitely you can score maximum marks. So students, here you can expect these 2 forms, the type 1 and type 3 for 8 marks, and this type 2 is for 4 marks. So here in this class I am going to explain about this third type, that is root A plus or minus root B form. Okay, so for this I am taking one example. So the example problem is prove that root 3 plus root 5 is an irrational. Prove that root 3 plus root 5 is an irrational. How we are going to solve this? How we are going to prove root 2 plus root 3 is an irrational? So here remember, the method that we are going to apply here is known as method of contradiction. Method of contradiction. So here under this method of contradiction, we have to assume opposite to the given statement. So here in order to prove irrational, we have to assume root 3 plus root 5 is a rational. Opposite statement for the given statement means the statement whatever we need to prove, we have to assume it opposite for it. So here first of all we have to consider root 3, that is, let us assume that root 3 plus root 5 is a rational. Why we have to consider root 3 plus root 5 is a rational? Because we are unable to prove root 3 plus root 5 is an irrational directly. Okay, so that we are assuming the opposite statement and applying for few operations, applying few steps, means after few steps we came to notice that our assumption is wrong. Why? Because we get one mistake, error. Okay, let us observe step by step. So here root 3 plus root 5 is a rational. From the definition of rational, the definition of rational is which can be expressed in the form of a p by q, where q is not equals to 0 and p comma q are integers. So here we have to assume the same thing here, as root 3 plus root 5 is a rational, means it can be expressed in the form of p by q, means it can be expressed as a fraction, right? From this we can write then root 3 plus root 5 is equals to a by b, or you may consider x by y or p by q. Okay, so here we have to apply square on both sides. By squaring on both sides we get root 3 plus root 5 whole square is equals to a by b whole square. Okay students, root 3 plus root 5 whole square is equals to a by b whole square. Now if you observe this, it is in the form of a plus b whole square. Algebraic identity we can apply here. So from a plus b whole square is equals to a square plus b square plus 2ab. In place of a we have root 3 and in place of b we have root 5. So try to substitute these values in this identity. We get root 3 whole square plus root 5 whole square plus 2 root 3 into 5, that is root 3 into root 5 is equals to, here it is a law of exponent, a by b whole power m can be written as a power m by b power m, that is nothing but a square by b square. Okay, so here square root gets cancelled. From this 3 plus 5 plus 2 root, here it is root a into root b form. Root a into root b can be written as root of a into b, that is root 3 into 5 is equals to a square by b square. So 3 plus 5 we can write it as 8 plus 2 root 3 5s are is 15 is equals to a square by b square. See here I am transposing the term, plus 8 transformed to other side of the equation becomes minus 8. So from this 2 root 15 is equals to a square by b square minus 8. As we are unable to identify any denominator, you may write it as a 8 by 1. Simply we can write 1 as a denominator here. Okay, so here we have to consider the LCM. We are going to simplify this. So this will be simplified as a 2 root 15 is equals to a square minus 8b square by b square. The LCM of b square and 1 is b square, and from cross multiplication 1 into a square is a square and 8 into b square is 8b square. And here 2 is multiplying, transformed to other side becomes division. From this root 15 is equals to a square minus 8b square by 2b square. It becomes a multiple here. Okay, after obtaining this step, observe this carefully. What is the RHS in this equality? As you find equal sign, equal symbol, we consider it as an equality, right? In this equality, this is RHS. Here the RHS a square minus 8b square by 2b square is a rational. How can you say it is a rational? If you substitute any value in place of AB, for any value of A and B, it remains as P by Q form. So the value which is in the form of p by q, we have to accept it as a rational, where both the numerator and denominator are integers. For all the values of a and b, this remains as a rational. And what about the LHS? What about the LHS? So here the LHS is root 15. What can we say about this root 15? So here we have one condition. What is that? If n is not a perfect square, root n remains as irrational. N is not a perfect square, then we have to accept root n as irrational. The same thing here, 15 is not a perfect square. 15 cannot be expressed as a square of any other number. That's why it is not a perfect square. As 15 is not a perfect square, so root 15, it remains as a irrational. Okay students, RHS is a rational, LHS is an irrational. As we have the equality, both should be equal, but it is wrong. How can we say it is wrong? A rational is not equals to an irrational. Both the set of rational numbers and irrational numbers are the disjoint sets. We are unable to find any common elements, right? If a number is considered as rational, then it is not observed in a set of irrationals. If a number is considered as irrationals, then it is not observed in a set of rationals. So it is wrong. Both are equals. So this statement is wrong, isn't it? So it is a wrong. It contradicts, means it is a contradiction, or it contradicts our assumption. It is a contradiction to our assumption. What is our assumption? What is our assumption? Root 3 plus root 5 is a rational. This is our assumption. As we assumed root 3 plus root 5 as rational, we got this error. Okay, means our assumption only wrong. As our assumption is wrong, we have to accept the given statement as correct. What is the given statement? Root 3 plus root 5 is an irrational, right? So here, after getting our assumption root 3 plus root 5 is wrong, is a rational is wrong, we have to accept, so that root 3 plus root 5 is an irrational. Hence it is proved. Hence it is proved. It completes the solution. Okay students, as root 3 plus root 5 is a rational, this statement is wrong, so that we have to accept root 3 plus root 5 is an irrational. So here it is an important concept, a point of examination, right? You can expect a long answer from this. Okay students, just to practice, it is the easy method which I have explained here. You can practice more problems in the same concept. Root 2 plus root 3 is an irrational, or root 3 plus root 7 is an irrational, or root 5 minus root 3 is an irrational. Okay, just practice and don't miss this concept. It helps you to get more marks in the exam. I wish you all the best. Thank you for watching. Have a nice day.